let's kind of get going with this. So this is what you guys told us. We had some really good registrations for this webinar. You can see the first question was around what distribution or Kubernetes service you're on. And the majority of you, 39% of you, said you are on Amazon EKS, followed by, looks like, other hybrid and DIY solutions. A few of you are on OpenShift and Rancher. So a good mix of people that are using a variety of Kubernetes products, software, and services here. So welcome. We'd love to hear your thoughts, see what questions you have as we go into the subject today. The second question we often ask as people come into Platform 9 is about what challenges they run into as they get their Kubernetes production clusters online and get their applications up and running. And predominantly, we hear that operational complexity is their number one concern. As you can see, 35% of you, and we have seen even bigger percentages in some of our people that come to our site. And you know, it's a pretty large problem, and there are other people struggling with getting their monolithic apps into microservices and getting Kubernetes up, using that for their applications. And you can see a bunch of other things, scaling, data management, but as you can see, Kubernetes operations is probably the biggest number one concern. We'll touch upon that today. There's a lot that Platform 9 knows about the subject, as we're business of running Kubernetes at scale and operating it. So I guess with that, I will turn it over to Chris, and I'll chime in for a few slides as we go forward. But what does it actually mean to run Kubernetes at scale, right? There's build, there's run and operate. It's not just enough to deploy Kubernetes clusters, and that's not the end of the game, right? There's much more to it. So Chris, I'll kind of hand it over to you to talk through everything that's needed to get production Kubernetes going.
Sure.
Over to you.
Thanks, Coach. Your audio is still doing strange things, so I might suggest you get Zoom to call your phone, and we go from there. Whilst Kamesh is reestablishing connection with us, I'll talk to build, run, and operate. When we look at a Kubernetes environment, be it one that we've built using our native stack, or be it EKS, AKS, or GKE that we're importing to bring under management, there's sort of three main areas that users struggle and that we try to focus on and help solve. And it also talks to the journey that most people and organizations go through trying to get to using Kubernetes in a production environment. Building it, generally covered fairly well by most providers. And today we're going to look at the way that you can do that on AWS using either Kops or EKS and sort of do a bit of a compare and contrast there, and the different outcomes and the different, I guess, capabilities that will bring to you. That's kind of the base, right? It's building the cluster and then handling upgrades, working with vulnerabilities, understanding, the challenges that come with how do I upgrade without causing an outage. Then maybe looking at how do I start leveraging things like auto scaling if I'm in the cloud, and leveraging some of those cloud primitives that are there, not a Kubernetes primitive. Depending on how I guess expansive your environment is, maybe there's requirements for bare metal and colos or your own data centers, as well as edge. That then introduces just a requirement to say, how do I then, I guess, build and keep these clusters running across multiple different clusters? Then when we move up the stack, we enter that layer that I like to call Kubernetes infrastructure applications. If we look at the world of VMs, everyone built VMs. There was apps. You could get the log files easily. It was fairly static. It was fairly unchanging. Routing requests to a service running on a VM generally just went through a load balancer. It was fairly uncomplicated. A lot of these things were either physical or became software defined. With Kubernetes, there's a bunch of stuff that you just have to run that comes with the cluster. That's not necessarily part of the cluster. And it's not necessarily evident when you're going on that journey of learning Kubernetes or trying to run something at scale. And some of those things are add-ons that you'll see in different Kubernetes vendors that are out there. Building in Prometheus for monitoring, so it's just there, so you can consume it. identity and access management integration, if you're in the world of AWS, and we'll touch on this today, that's kind of a key piece. Being able to have an identity that is authenticated and then using Kubernetes RBAC to do the authorization. That's not a simple thing, and it's not necessarily out of the box either. Setting up ingress and load balancers required for Kubernetes, not necessarily native and just in a cluster once you've built it. And then once you've got that base layer running, you start saying, well, how do I make sure this stuff is running? How do I make sure that cluster is healthy, not in the cluster alone, but also outside of the cluster? How do I start improving my resiliency? Is there something in the cloud I can use? Is there auto-scaling groups that might do that? Is there a node health detector I can run there? How do I start looking at governance and solving there? How do I get help? How do I troubleshoot this? If I've gone completely open source, am I just going to a Slack channel, a message board? And importantly, where is the right place to run as well? So when we say build, run, operate, it's not just saying I'm operating a cluster, it's saying holistically, what is required at Kubernetes? What's required at that level? And what do people need help with as we go along that journey as well? So hopefully today we're going to touch on some of the build run aspect of EKS as well as Kops, looking at some of the tooling and add-ons that are there. And then we'll touch on at the end some of this operate layer, some of the challenges that come in once you're up and running as well.
Terrific. Chris, thank you. I hope I'm back. I'm still having some internet stability issues, but hey guys, feel free to ask questions along the way. You can use the Q&A button or use the chat window. Happy to answer them along the way. And of course, we'll have time towards the end if you have specific questions around your use case. Why don't we kind of dive into the actual topic of the day? We're going to talk about Kops and EKS for the rest of the session. Chris will kick it off with a quick sort of level set around Kops and EKS around support and requirements. Then we'll dive into the details in a bit. Chris, back to you.
Cool. So we just thought we'd put in here for people that are learning Kubernetes or, maybe think, I want EKS, should I try Kops? Or I'm on Kops, should I try EKS? What's required? Both have a very similar level of sort of prereqs to get up and started. Up front, let's look at Kops. What does it support right now? In general, availability for support is AWS, Google and Azure are in alpha. And there's a few other sort of smaller providers out there that we find on the Kops documentation in various states of alpha and beta. Today, we're looking at AWS specifically. What's required to get up and going? You need to have an account first and foremost. You need to have the ability to create new roles and configure identity and access management for users as well. That's a gating factor. That's really a gating factor for doing anything on AWS. So I'm going to assume most people have that. Kops takes an opinionated stance on DNS, and therefore Route 53 and domain management is also a prerequisite there to get up and running. Some great documentation there. It will take a bit of time to get through, and we sort of touch on that upcoming slides. Once you've got that done, you really want to make sure you've got the AWS CLI, Kops CLI installed. Eventually, kubectl as well will be required. So not too dissimilar to many other variations of Kubernetes. On the next slide, we'll look at what's required for EKS. That was pretty similar stuff as well. So you need your CLI access to your routes and domains as well. Route 53 is not a hard and fast for EKS. It can help depending how you want to route things in. You will need a VPC created. You want the AWS Identity and Access Management Authentication CLI. That will really help simplify things. And there's also a fairly new piece out there, the EKS CTL, which can also help with building clusters and managing them too.
All right. Thanks, Chris. So folks, one of the things we wanted to mention was as part of our exercise here at Platform 9, we spent several days to actually perform hands-on. What does it take to set up, install, deploy, and perform day two activities with each product? So we went hands-on Here you're seeing some screenshots of the kinds of things we've done. Kops, here's an example of setting up etcd, CLI commands that you need to go through. Same thing with EKS. As Chris was saying earlier about the whole setup experience, here are all the activities that are needed, right? If you think about that build, run, operate paradigm that Chris was talking about earlier, there are a number of activities that are needed. So we actually perform these activities against Kops and EKS. So you can see the initial setup. It's not just deploying the basic cluster, but it's setting up monitoring and logging. It's setting up RBAC. It's ingress. It's setting up core DNS, whatever storage you have, whether it's in AWS. And then for networking, there's several options. Of course, Calico being the thing that we recommend for real scale-out networking within Kubernetes. So just getting a fully functional, production-ready Kubernetes takes a number of initial setup steps. Now, how easy it is to do it with Kops versus EKS, that's really what the exercise was that we went off and did. And I'll share some of the results with you shortly. But once you have the cluster up and running, you have all the components, all the add-ons, everything ready to go, and your applications are up and running, now you have to deal with ongoing lifecycle management, what we call day two operations. And here there's a whole bunch of things, right? There's upgrades as you get new versions of Kubernetes. 117, now we're at 122. So as you know, the community the velocity of new releases is extremely fast, every 3 months. Then there's security patches that are happening on an ongoing basis. You have to scale your cluster. Maybe you have use cases that deal with multi-cluster, multiple clusters of Kubernetes, or even multi-cloud. And what happens when things fail, right? Troubleshooting and keeping your cluster up and down. So there's a lot of considerations here. So I wanted to kind of show you real quick, what we found at a high level. And maybe Chris, you can chime in. What we noticed is with Kops, essentially you are pretty much on your own, right? You get the Kops CLI, you download the pieces, you get up and running, but everything else, right? Whether it is getting your networking up and running, whether it is getting storage integrated, getting load balancing, cert manager, metric servers, none of that is quote unquote included in the sense of being managed or version controlled. It's completely on you to get these things installed, integrated, and managed all by yourself, which in some cases may be fine if that's, if your clusters are small. We'll get into a little bit of the decision criteria shortly. And with EKS, as you can imagine, many of these things are managed, right? For example, networking, you have the Amazon VPC and subnets, which kind of come quote unquote built in and managed by Amazon, AWS. etcd, for example, is entirely included as part of the control plane, but you have no access to the masters, right? You have storage, you have S3 buckets, you have all kinds of storage options. You have obviously the AWS load balancer controller. Some things are not available out of the box. For example, cert manager, it's not included. You've got to do your own installation and your own configuration. Same thing with metric server. DNS, of course, they have Route 53, but it's not as straightforward as it seems. And I'll show you in a bit our exercise and what we found with that. There's a bunch of configurations and activities and manual steps you have to do to get it up and running. Monitoring and logging, again, in the case of Kops, it's not included, but in the case of EKS, you can use CloudWatch, and there's a whole bunch of container logging that AWS has included recently. So at a high level, this is what's included with each of these two solutions or platforms. So here's a I know there's a lot of stuff here, but I wanted to quickly give you a glimpse. We have written up a very detailed doc about this. So what you're seeing on the screen is all the activities, all the criteria, and what it took to actually do it with Kops and with EKS. So we logged the time, the number of hours it took to get it up and running, how many manual steps are involved with each of these activities. And you can see this is just the initial setup, right? And I mentioned all of the different activities: deployment, setting up monitoring and logging, RBAC, identity management, DNS, storage, and so on. And with Kops, it took us literally greater than 16 hours to get the basic setup up and running. With AKS, as you can imagine, it's much less. It's 50% lower. But it isn't like a, click a button and everything works, right? So clearly with Kops, everything is manual. You're using the Kops CLI, you're using kubectl, you're using, all of the tools. But you can see that you're deploying everything from scratch. For example, for monitoring and logging, if you want to set up Prometheus and Grafana, it's all open source stuff. Obviously, there's no warranty or any support for any of these things. You're completely on your own. Even setting up DNS requires, third-party domain registrar. Setting up requires a bunch of steps there. Calico is probably the most complicated, and it took almost an hour for us to get Calico up and running. 7 steps there. Load balancer is equally daunting. Lots of additional configuration required on Kops. But the interesting thing is, even with EKS, now Chris was mentioning earlier about EKS CTL. Now, a lot of these steps are in fact automated with EKS CTL, but the downside, of course, is once you start using EKS CTL, you're pretty much stuck, locked into the EKS and AWS ecosystem. So that's a trade-off. You want something to get going very quickly. EKS CTL will do all of that. You can use all of these services from Amazon from the get-go: CloudWatch, AWS IAM, AWS Auth, right? All of the drivers that come, the CSI drivers that come with it. Well, surely you can get everything up and running at 50% of the time, but clearly you are very much in the Amazon ecosystem at this point. And day 2 operations is, as you can imagine, again, it takes time with upgrades, security patching, scaling, etc. And one thing I want to point out on this slide is specifically multi-cloud, and we'll get into this in a second. There is no native solution in Amazon. Now, they recently announced what is called EKS Anywhere, which will allow you basically to run EKS quote unquote anywhere, whether it's on your on-prem data center or what have you. But again, there is no native solution for multi-cloud. If you truly want to go multi-cloud, if you go into AWS, it's going to be very difficult for you to kind of move out of there. So I'll pause here, and maybe Chris, I'll hand it back to you in terms of, all this is great. You've got Kops, you've got EKS running, but the question still remains: who's responsible when something goes wrong? Inevitably in production, things are going to go bump up and somebody has to deal with it. Back to you, Chris, if you could answer, can take this slide up.
Who's responsible when items break? This is a hot topic. Open source is a great thing. There's different opinions around the world and in different industries about what open source could and should look like, and how to, I guess, best make value of that from your organization. Platform 9 was founded on making open source easy and accessible to everyone. And one of the big factors that sort of impacts adopting anything that is completely open source is team size, as well as risk to the organization if there is an outage. EKS does bring in support. AWS does have different levels of support you can go and buy from them when you're using their products and services. If you do want, super hands-on, technical account manager with solution architecture and define people who you can reach out to and interact with, that level of support is there. If you just say basic level, I've signed up for AWS and I'm using EKS, and I've signed up for AWS, I'm going to use Kops to build a cluster. Who do I go to for help, and who's going to help me when I hit a problem? EKS obfuscates the control plane, and that really does put the pressure on EKS to help and support you there to make sure that it's viable and running. If you're using Kops, Pro, you get to build the masters, you get to choose the availability zones that they're in, you get to choose like the node group and making sure they're all nice and tidy and self-contained and they won't, take each other out. You might get to have the ability to set different API server flags and scheduler flags and controller flags. But with that flexibility comes a whole bunch of risk. It requires a lot of investment and knowledge. And if something does go wrong, you're really reliant on the community to get that back up and running. There's no sort of companies out there that are offering production level support on top of a Kops cluster. And that paradigm for getting help continues, right? You have a problem with etcd, or maybe there was a new etcd release and you decide I'm going to upgrade straight away and there's a bug upstream from there. Or maybe the same thing has happened with, your container runtime that you've chosen to operate your cluster within. You've decided to do an upgrade that as well, and that's now causing application problems. You're going to be dependent on going to that upstream community and asking, hey, what's going on here? Posting issues on GitHub. And it's almost like a list that is never ending. And this could be, 100% stable. And then all of a sudden you upgrade Cert Manager and that stops issuing certificates and you have an application outage. So it's not like it stops at the cluster. It's all those infrastructure applications that you're adding on top of are something that your team is going to have to own and try to operate. And it's that balance, right?
Yeah,
are we going to do all this in-house? Where do we go for help if we need it?
Yeah, it's a question of how much can you afford to lose time, to downtime effectively, right, Chris? I mean, it depends on how critical your application is and what is the tolerance level of your cluster going down and how long you have to troubleshoot. I guess it really comes down to that at the end of the day, right? Chris, you've seen some of our customers really have, especially in the fintech world or in the manufacturing world, where the cost of downtime can be very, very high and you just cannot afford to be working with the community while your systems are down, right? So I guess it really depends on what level of resilience and reliability and uptime you need to have. That's one dimension of it. The other dimension is, as Chris was saying, right? I mean, do you have the skills and the people in-house that can fix it very quickly or get help as needed? So this is where the trade-off comes. With EKS, you get some of that from EKS, from Amazon. Some of it is fully managed. As you know, the control plane is fully managed, and Amazon AWS actually gives you a certain level of SLA, which you can rely on. But for a number of other things, especially the add-ons, the cert managers and the networking, if you're using Calico, you've installed it yourself. And if something breaks there, again, you're on your own, and so on. So it really, where you fall on the spectrum is important.
I think it's also important to sort of call out here. Mm-hmm. If you are going down the Kops route and you're looking for a CNI in the networking space, you could choose Calico Enterprise. And go to Tigera, get that, and get support. Storage, you could say, I'm going to go with Portworx. They seem awesome. They're cloud native, and get storage. Load balancer, you're going to be leveraging something from AWS. Mm-hmm. So technically that's got, support, but if you're having challenges with using Kubernetes on it, once again, you're back to your in-house support. You don't have to use Cert Manager. It's just an open source, a tool that is available. Metric server, you don't have to run that in your cluster. You don't have to worry about upgrading it. You could just leave it out. DNS, you do get the flexibility to go, external or just Route 53. But once again, if you're struggling with that interaction layer, you're going to be reading docs and reaching out to the community, maybe going to an office hours or two to try to, get something fixed. And then monitoring and logging, you don't have to choose Prometheus. I come from a background where all application performance monitoring products were, vendor built. And there's great solutions out there that will work on both of these platforms that, should just plug and play and really help solve that monitoring and logging pain. But what that results in is multiple different vendors to go to for support. And when things don't work, it's more often going to be that application interacting with Kubernetes. That's the problem. And that's where a lot of time is spent circling and trying to figure out, why something isn't doing what it should be doing.
Yeah, great point. I mean, logging Datadog, for example, you works with Kubernetes too, and it can work in Amazon or on-prem, wherever you want. Yep. So let's take this one step further, folks. I mean, this is all, we're just talking about one cloud and one cluster. Now we're starting to increasingly hear about multi-cloud. And you can see we've over the last year, Chris, you and I are in the industry for several years, and we'll talk about some of the evolution here in a bit. But this is becoming more and more prevalent, and this is some data from a variety of sources, right? So Flexera puts out a state of the cloud report every year, and 4.9 is the average number of clouds in use by enterprises and companies. If you think about that, that's mind-boggling, which means on average, a company or an enterprise is using almost 5 different clouds, whether it's Amazon or Google, it could be even DigitalOcean or IBM. It's mind-boggling to think that there's so many clouds being used, and I can kind of speculate on it and think why that would be the case. I feel like a lot of that has to do with which cloud is good for what. I mean, for example, I would use some of the AI, machine learning, data lakes, and data analytics capabilities that Google offers. It's probably the best in that area. And if I'm in .NET shop or Microsoft shop and I need to have Windows stuff, then I probably go to Azure, etc. Right? And Amazon has a bunch of related services that you might be interested in. I think that's what's driving it. This just use of multi-cloud with all different clouds there, and there's this new buzz. I mean, recently we've been following. There's this blog that came out from Andreessen Horowitz about a couple of months ago. It caused a lot of controversy and lots of debate in the community. The blog was about the cost of cloud and $1 trillion paradox, right? Essentially, at a high level, what Andreessen is saying is if you are scaling in the public cloud, it's great to start in a public cloud. If you're a startup, you don't have the resources, you don't have data centers, you don't want to manage any of that stuff, great, get started in a public cloud. It gives you speed, agility, you can get going with your business, get your applications out, time to market, all of that great stuff. Fine, do it. But once you reach a certain stage of scale, now they're saying, you can read this article, it's really eye-opening. They're saying your operating margin as a public company or a SaaS company is going to be impacted by almost 50%. And overall, they're saying, $4 billion is the estimated gain when you get out of the public cloud and repatriate, back to on-prem or, other possibilities there. We're hearing a lot of this from Gartner too. A recent Magic Quadrant from Gartner is basically saying that a lot of companies are starting to feel the pressure from the public cloud companies around, renewals and, a lot of issues with just scaling out in the public cloud. And the other kind of market trend that's happening is a lot of the workloads are now moving to the edge. If you think about IoT, if you think about automated vehicles and 5G and automated retail stores and all of this stuff, a lot of the data will start to move out to the edge. And maybe this is not your use case, but maybe in the future there will be a use case where you'll have to think about, okay, what do I do now? I mean, I've got started with EKS. I'm starting EKS CTL. I'm using all of the proprietary Amazon services, whether it is IAM, S3 buckets, VPC networking. Now I need to start taking these workloads and moving out to the edge. At that point, then you're now stuck with this issue of lock-in. So I just wanted to quickly talk about this in the context of what's been happening, right? Let me quickly kind of walk you through. I've kind of seen this myself firsthand. If you think about back in 2011, almost 10 years ago, there was no Kubernetes. But there were platforms, right? There were containers. Containers have been around forever. I mean, in fact, they were even in IBM mainframes and Solaris operating systems. But there was container orchestration. There were platform as a service platforms, and many of you who've been around probably know Cloud Foundry. They probably know Docker orchestration. Mesos was a technology. All of these guys were kind of focused more on sort of the PaaS layer, if you will. They were very opinionated. They were kind of popular back in the day. I was part of the Cloud Foundry community for a while, etc. But this is all pre-Kubernetes. So the challenge with these things were that they were highly opinionated. They worked great for certain use cases, but there was not this open community, and some of them didn't take an infrastructure view at all. For example, Cloud Foundry was an entirely developer focused, right? Click on a button, git push, that's it. Your application is up and running. They had their own container stuff. But fast forward to a few years, 2015, that's when Kubernetes burst into the scene, and a bunch of tools started emerging, right? Rancher, as you know, which got recently acquired by SUSE, and OpenShift essentially basically pivoted over to Kubernetes as the underlying platform, as did Cloud Foundry, as did Docker. I mean, pretty much at that point, everybody in the industry and the community embraced Kubernetes. And that's when Kops came into being, right? Because people realized that Kubernetes needed to be operated and you need all these tools. And, as we just talked about it, right? So the Kops by itself was great when it started. A lot of people got started with it because there were no other alternatives, open source alternatives at the time. They would use Rancher or OpenShift. But again, fast forward a couple of years, that's when we got into the third generation. This is where the big three, Google, Amazon, and Microsoft, got a lot of pressure from their customers. And I know, because I have colleagues at AWS does not do anything until customers say they need it. They're a highly customer-focused company. And the fact that they embraced Kubernetes and came out with EKS back in 2018 is testament to how popular Kubernetes had become, but also how complex it was, because people didn't want to deal with all of the complexity of deploying and the build, run, operate paradigm we just talked about. So there you go. You got the monocloud services from these three major vendors. And it's a single cloud. Once you're in EKS and AWS, you're in there. I mean, that's your choice, right? But then, as I said earlier, this multi-cloud thing is starting to emerge. The cost of public cloud at scale is becoming apparent. So now we're entering this, what we call the fourth generation, more like this multi-cloud SaaS-driven, SaaS control plane-driven kind of architecture and platforms. And the number of players have emerged here. So Platform 9, we've been doing this for several years. We started off with OpenStack, but the idea is the same. You have a kind of a hybrid multi-cloud, cloud agnostic way of approaching workloads, right? So we'll talk briefly later on to tell you how we do this. Google Anthos, EKS Anywhere, VMware Tanzu, all of these we believe are new offerings that are these fourth generation. And as companies start to move into multi-cloud and hybrid, they have to start increasingly thinking about this way of operating their Kubernetes clusters. So let's go back to the build, run, operate paradigm. So Chris, let's go back here and kind of map these build, run, operate back to the tools, right? You have Kops, where does that fit? And you have EKS, and you have these fourth generation tools. So why don't you talk to this, Chris, real quick? So we have Kops, EKS, and Platform 9.
Sure. It's really just sort of looking at where do these tools help in your organization, and what will you need to go on and figure out by yourself in and above just sort of building that base cluster, right? A lot of that stuff that we went through, it takes time up front. You might be able to automate it, but Kops is always going to live in that build and run. Managing more and more of those infrastructure applications is strategically becoming more important to all Kubernetes vendors and operators out there. And Kops is adding in add-ons, and they've got a framework that you can leverage as well, which is good, but it's still in that build and run space. If we look at just EKS, and where we're not talking about going to AWS and asking for additional services there, EKS, because it's on AWS cloud, it inherently has more adjacent cloud services that you can leverage. And it will move up into that stack and help you solve some of the problems that are in running those add-ons and that tooling, because you're paying for a service from AWS. Therefore, they will need to help you as well. So it inherently reaches up higher into the stack of building and running and then operating clusters at scale.
Right. Well, one thing, Chris, I wanted to mention here. Now, the layer at the top, the operate layer, look at all the things that are involved here. There's governance, there's remediation, troubleshooting. By the way, EC2 instances that are running the worker nodes is still your responsibility with EKS. Now, of course, they have Fargate, they have a bunch of other things, but essentially you're on your own. If a node goes down, like one of the EC2 instances goes down, some of the Kubernetes might move your workloads over to other pods, etc. But dealing with that node is still your issue. You still have to deal with it. What if it runs out of disk space, or what if there's a networking issue, etc. Right? What if the kubelet service in there or Docker daemon goes down? You still have to deal with that, and you have to troubleshoot, fix it, etc. There's governance. There's RBAC at scale. There is RBAC that EKS provides, but at a single cluster level. So, Chris, you can probably talk about what happens when you have multiple clusters, and what if you have multiple public clouds that you're running your Kubernetes clusters on? How do you then manage governance? If you could talk to that, and then we'll see that there are a number of things that are still on your plate to handle.
Yeah, I think that's a really important aspect. Some of the partners we work with that have large environments and have multiple clusters that span dev, test, production, they have real problems where developers are given clusters, they go and write their software, deploy their containers, see how it runs, and all of a sudden they're like, well, the app's working, but it's not running the way I want it to run. So they might go and make some changes at that Kubernetes layer, or they might go make a new service account that application is going to leverage, or that integration is going to leverage, and they'll change some RBAC policies around that. And then all of a sudden they check in their code. They don't check in anything around the cluster changes, and it deploys into their test environment, blows up. Or worse, there's an automated pipeline and it gets to production and those changes aren't in production, but they were in test and dev, and that's now failing. And that's just internal to one company. And that is purely just focusing on role-based access control, as well as something that's tricky. If you're running multiple clusters across multiple clouds or multiple different locations, or maybe your own data centers, or even just in EKS or AWS, having something that can help manage and govern the consistency of roles and access across clusters is truly important. You could obviously do this manually. You could say, kubectl, get all my roles, get all my cluster roles, get all my bindings, export them, put them into GitHub and version them, and then apply them down into each of your clusters to keep them consistent. But then how do you know if they've changed? You need something that's going to be in that cluster that's managing that state, or you're going to have to be doing a diff between them, leveraging something like Visual Studio Code and trying to compare, like, what is the difference between these two clusters? Like, what's different? These aren't things that are naturally built into something that's managing a cluster, because it's just managing the cluster and that infrastructure and those basic add-ons that are there.
Right. And so clearly, the challenge still remains, and your mileage might vary. You might have a team, you have the skills, you go all the way up to the top, right? Maybe you don't have some of these additional capabilities like governance that Chris was talking about, et cetera. So, this fourth generation that I was mentioning earlier are starting to move into this area now, right? So the multi-cloud capabilities, the ability to manage the entire thing, right? So you don't have to worry about build, run, operate, all three layers. And companies are emerging in that layer, and we'll say Platform 9 is an example of a company that provides that full management end-to-end, where all three layers are managed for you in a collaborative fashion. I wanted to quickly switch to the final topic of this webinar. And like I said, feel free to ask questions. I think we're kind of entering into the Q&A phase shortly. So look forward to deeper interaction here. So the question ultimately becomes, how do I make a decision, right? Should I use Kops? Should I use EKS? Or should I go fully managed, right? As we've been saying throughout this session, if you don't need any help And if you have a relatively small scale of operation, let's say less than 10 nodes, and you have a moderate team size and you feel like, hey, we can manage this ourselves. No help is needed. Outside help is needed. And also, we're going to just stay with AWS, right? And you don't have really high, mission critical applications and high uptime requirements. Hey, then knock yourself out. Kops is your best solution. Now, on the other hand, as you start moving into kind of larger deployments and more mission critical stuff, and your cost of outage starts to increase, you're starting to do more production, customer facing applications, and like we've been saying, any downtime is going to impact your customer experience, your revenue, and your operational efficiency. Then, unless you have a big enough team, you'd want to probably go with EKS at that time. Again, here, the trade-off is if you want to stay AWS only, EKS is a great solution, right? Because then you've made a decision, you've kind of said, okay, monocloud it is. But all indications we're seeing from every company that we interact with, all of our customers are already multi-cloud, whether they know it or not. Then eventually down the road, they're going to face the issue of governance. We just talked about it, right? How do you manage access control? How do you manage costs? How do you optimize costs across all of these different clouds? It's not an individual DevOps engineer or an individual DevOps team issue. Now it becomes an enterprise-wide issue because now the CFO and the CEO is asking the question, why are we spending so much on all these different clouds? And then you'll realize that 60 to 70% of the capacity is wasted, which is what happens today in the cloud. So those are some of the trade-offs when you're kind of all in with EKS. Well, there's also this last option where you could go with a fully managed solution like Platform 9, where your team is now getting help in a collaborative fashion as a partnership, right? Where you get some build coverage, you get run and operate coverage. You are now truly multi-cloud. You're agnostic to any one particular tool set. If you use EKS Scuttle, for example, as I was saying earlier, then you're pretty much stuck there. I mean, you could argue I can use something like Terraform or some other third-party tooling to make it agnostic. But I even there, Chris, I think I would argue that even there you still now have to manage all of these automated scripts on your own, right? I mean, what would it do if you use Terraform and say, hey, I can do multi-cloud with Terraform? What are your thoughts on that?
I think the question is where, if you're leading a team of engineers or running a business, I think the ultimate question is where do I want my people spending their time? What's really high value to my organization? Yeah. And how do I best service my customers, both internal and external? Yeah. Kubernetes is more complex. It moves every 3 months, and it's not just the cluster you need to worry about. It's the other applications you have to operate to make it work. And early in my career, I sort of experienced working at a bank in Australia in a really highly performing team where, that focus of build and run was automated and covered to such a high level, but it was using physical machines and virtual machines where the rate of change was much lower. And that meant the ops teams were actually able to work on projects. And if you've got an ops team that's just running Kubernetes clusters, I'm gonna say they're probably not contributing much more value to the business than just focusing on running in Kubernetes.
Yeah, great point.
So I think that's the question. EKS is going to help, right? Running Kops on AWS will alleviate that infrastructure-based problem. It's where do you want the team to focus and what value are you driving to the company? Mm-hmm. And if you're okay writing those scripts and developing those things, and wherever you're building clusters and whatever way you're executing that base task of, hey, build this thing that doesn't now exist, you're probably going to use some form of script. It's probably going to be some form of Terraform or Ansible or any other of those solutions that are out there. Mm-hmm. What happens when that doesn't work? That's the question.
Right. Back to the I have to manage this myself and I'm not focusing the time on adding business value, right?
Correct.
Yeah,
Correct.
Great point. Yeah. Great. I think we're kind of almost getting here to the Q&A session. So Chris, I think maybe you just want to quickly give the audience a quick overview of, the Platform 9, the Generation 4, the SaaS-based thing we've been talking about, kind of contrast and compare very quickly at a high level against EKS.
Sure. So as a company, Platform 9 was founded in the cloud. We're very well positioned to therefore deliver hybrid edge, public cloud, private colo infrastructures as a service, going from managing that bare metal all the way up through into Kubernetes, as well as managed virtualization. Our SaaS control plane is something that we manage for you, that we do all the upgrades, so you don't have to install it. All you're doing is connecting your infrastructure to our SaaS management plane and then going out and building those clusters. And where we really pride and value ourselves as a company is to make that so simple for both you as a user and us as a business that we're able to then really help with that next order of problems. How do I get my CI/CD tool to work properly? How do I do role-based access control governance across all of my clusters? How do I get my application to deploy and be stable and operate? These are all things that our solution architecture team, our support really do focus in on and help all of our customers today. It's not just about that build and run of the cluster and add-ons that we're providing that come part of that and the automation we provide. It's moving up that stack. And if you are challenged with running Kubernetes at scale, to me, it's going to be something that doesn't get any simpler as we move on. It's just going to get more and more complicated. And I'd really sort of ask everyone to think, where do I want my team, or where do I want to be spending my time as well? And from that, I think we should go to questions.
Let's get to questions before we get into this. So feel free to ask any questions, folks, at this point. We'll see if there is one question that I'm seeing here. Chris, probably it's a good question for you. This multi-cloud thing, right? So what's the benefit of? I guess the question is, how do you make this multi-cloud governance and management easier?
Sure. So if you are doing multi-cloud, which we see a lot of users looking at and running, some of it's to basically give your CFO a bit of a break for some cost arbitrage, because you can say we can run services elsewhere. But once you've sort of made that decision as well, how do we run consistently? The approach that Platform 9 has taken is we will build our clusters natively in AWS and Azure on-premise and data centers, but we'll also import EKS, AKS, and GKE. And then we're focusing on simplifying the operations above that cluster. So role-based access control is the first piece of governance that we're targeting. It's in a new feature that's rolling out this week called the Profiles Engine. And that allows you to template and snapshot your cluster configurations, apply it out to other clusters, and then manage the drift in real time between those clusters. So you can see where things have changed and if your clusters are consistent and whether or not that's something that's impacting your environment in real time. So that's one example. Yeah. Add-ons is another example that'll be rolling out from September onwards, is being able to say, just add metric server, add Kubernetes dashboard, add the monitoring stack, and all of that becomes owned and life-cycled by Platform 9 on top of those clusters consistently, no matter where they're running.
Right. Along those same lines, there's another question here. We talked about governance, we talked about management. How does that compare with Anthos? So let me take a quick crack at that, Chris, and I'll bring that back to you. And we have run into Anthos a couple of times in the field, and customers have obviously done the bake-off between them and us. One of the things that I notice, and Chris, you're closer to some of these customer deployments, so feel free to chime in. I think one of the issues that I think is Anthos requires VMware in order to run on premises. So, there are two things to think about here. There's multi-cloud, which is, can it run on different public clouds, right? Can it run on Amazon? Can it run on Azure? Can it run on DigitalOcean? The other aspect of it is, does it run on premises in my current data center? Can Can it run on bare metal? Can it run on VMware? What about edge? So if you think about the edge deployment, so we've done a number of 5G deployments, and we can speak to that use case all day long. We've got very large deployments where you have hardware sitting under a cell tower, right? And there is intermittent connectivity to it, like I'm experiencing today. Your internet goes off, and your systems still need to continue to work, right? So those are all the scenarios, and I feel like Anthos isn't still there when you think about true distributed, data center, edge, and multi-cloud. That's my opinion. Chris, you want to chime in?
I think it's great to have competition. This is a space that we started in 7 years ago. And when Anthos first came to market, that was something we looked at and sort of said, look, this is really validating our approach to the market. There's always going to be pros and cons to every solution that you go with. If I look at Anthos from a independent standpoint, if I was running a business, if I was back at working at a bank, do I want to be involved with Google to that point? Where is my identity management living? How do I holistically run my entire IT operation? And am I founding that on one particular cloud? That would be kind of the first question that I'm asking. Anthos has some great features that are in that platform that will help. Honestly, that will make building and running clusters much simpler. It's going to have that trade-off of it's going to be more Google Cloud centric. Of course, that's their main objective, is to drive that adoption. But it's going to help you build and run multiple clouds or multiple clusters across multiple clouds. It's that question of independence and cloud locking that enters my thoughts when I look at Anthos.
Yeah, I mean, if you think about any public cloud vendor, right? Think about their business model. Their business model, AWS, Google, their business model is they make money when they sell or rent infrastructure, in this case, or infrastructure services. So, I mean, they will say they're launching on, Anthos. I think Google has announced that they will run anywhere, including AWS. But I would question how much they would actually enable. So I'll guarantee you, and Chris, I don't know if you've done any actual comparison work where services that run on Google Cloud would probably be richer and more complete than services running on AWS. My guess, right? I mean, that's how it would be, right?
Yeah, there's another question that came in and says, is OpenStack providing the infrastructure abstraction layer similar to Anthos relying on VMware?
Yeah, good question.
In this diagram that's on the screen there, I just put bare metal in between. You don't have to deploy with our bare metal. Our managed bare metal solution is leveraging OpenStack, but we run OpenStack as a control plane. It's SaaS. We manage it, we version it, we upgrade it. All of that is completely obfuscated. If you're looking at Kubernetes on bare metal, we literally just create a point of presence in the data center that connects to those bare metal nodes. And from that point, you can one-click provision them completely into a fully functional managed Kubernetes cluster. If you've got VMs or physical servers, our managed Kubernetes will also just connect to it as a simple agent installation. So we don't require anything anywhere. We're literally just tunneling from that infrastructure securely out to our SaaS management plane. Our single sign-on uses SAML that then gets plumbed down into those clusters. So you're also not getting trapped into any single identity provider or platform, or you can generate identities within our platform as well.
That's a good point. That's a good point. I think the more open you are with the tool selection, the better your chances of, being free in terms of multi-cloud and your ability to run your workloads, quote unquote, anywhere, which ultimately I think should be the goal of any cloud architect, any DevOps engineer. Maybe it's not your use case today, but eventually down the road, if you think long-term, everyone's going multi-cloud and you want to stay as open and as free as possible from being locked into any one provider.
Yeah, I mean, my personal experience with this was, with my previous employer, we built a a whole new generation of applications and they were using what I would call a cloud native service, the cost of it went up. Profit of that service to market went down. And because it was using that native implementation, it was a database service, there was no way to arbitrage that against someone else. It was re-architecting the application. And there are real challenges that people do face.
Yeah. Excellent. I think we are pretty much done. No further questions. We're at the top of the hour. Really enjoyed this conversation with all of you. Thank you so much for attending. And Chris, thank you. It was a great conversation. I hope everybody got value out of this session, that you've gotten a better understanding of Kops EKS. We do have a much deeper document that walks through the comparison in detail, which we will follow up with in a post-webinar follow-up. I would suggest if you want to really try Platform 9, sign up for a free service. You can get going within a few minutes. It's all free, no credit card required. And if you have advanced use cases, you want to talk about multi-cloud, edge, feel free to reach out. The contact information is over there.
If people want to continue any discussions, just head to our Slack channel, slack.platform9.io, sign up. I live in there, so do a bunch of our support guys as well. So if you have questions or challenges around Kubernetes and want help, jump in. We also have another webinar tomorrow where we're getting into the details of Rook and operating that within a cluster and how it's architected and how to architect it for your cluster as well. So check that out. If you are looking into Rook as a storage solution or just open to learning more.
Thank you, Chris. And thank you everyone for joining us today. Have a great rest of your day. We'll see you soon in a future event. Take care. Bye-bye.
Thanks everyone. Bye.